In the summer of 1943, while the world was engulfed in the chaos of World War II, a quiet revolution was taking place in a small hangar in Stratford, Connecticut. The sound of metal being shaped, engines being tested, and blueprints being revised filled the air. But this wasn't just any aircraft development facility. This was the birthplace of what many military officials dismissively called a toy helicopter. The woman behind this revolutionary machine was Dr. Helen Carter, a brilliant aeronautical engineer who had been fighting two wars simultaneously, one against the Axis powers and another against the skepticism of her male colleagues who couldn't fathom that a woman could design something that might change the course of military operations forever. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Helen's journey began long before the war. Born in 1915 in rural Kansas, she had always been fascinated by flight. As a child, she would spend hours watching birds, studying how they maneuvered through the air, how they could hover, dart sideways, and land with precision that seemed impossible for the clumsy airplanes of her era. Her father, a mechanic, encouraged her curiosity, teaching her about engines and mechanics in their small garage workshop. When she graduated from MIT in 1937, with a degree in aeronautical engineering, one of only 3 women in her class, Helen immediately began working on what would become her life's obsession: vertical flight. While her male colleagues were focused on making airplanes faster and more powerful, Helen was captivated by the idea of an aircraft that could take off and land anywhere, hover in place, and navigate tight spaces with the grace of a hummingbird. Her early prototypes were crude, often crashing spectacularly in the fields behind her Connecticut workshop. The local newspapers occasionally ran stories about the lady inventor and her flying contraptions, usually with a tone that suggested she was an amusing curiosity rather than a serious engineer. The military contractors who occasionally visited her facility were even less kind. General Morrison, a procurement officer from the War Department, famously told her in 1941 that the Army needs real weapons, not toys that spin around in circles. But Helen persisted. She understood something that the traditional aviation industry didn't. The future of military aviation wasn't just about speed and firepower. It was about versatility and precision. Her helicopter designs incorporated innovations that wouldn't become standard for decades: advanced rotor systems that could operate in extreme weather, compact engines that provided exceptional power-to-weight ratios, and navigation systems that allowed for precise maneuvering in confined spaces. The breakthrough came in early 1943. Helen's latest prototype, the HC-7, successfully completed a series of test flights that demonstrated capabilities no fixed-wing aircraft could match. It could hover motionless for extended periods, fly backwards and sideways with equal ease, and land in spaces no larger than a typical city parking lot. Most importantly, it could carry a significant payload while maintaining its maneuverability. Word of these successful tests reached Lieutenant Colonel James Patterson, a forward-thinking officer in the Army Air Forces who had been advocating for unconventional approaches to military aviation. Unlike his predecessors, Patterson recognized the potential of Helen's invention. He visited her facility in March 1943, just as she was preparing for a demonstration that would either validate years of work or confirm the skeptics' dismissal of her toy helicopter. The demonstration was flawless. Helen piloted the HC-7 through a series of maneuvers that left Patterson speechless. She flew the helicopter through an obstacle course that included tight turns around buildings, precision landings on elevated platforms, and a rescue simulation where she had to hover next to a second-story window while a volunteer climbed aboard. The aircraft performed every task with a stability and precision that exceeded anything Patterson had seen in conventional aircraft. "Dr. Carter," Patterson said after the demonstration, I think we need to have a very serious conversation about your helicopter. That conversation would change everything. Patterson arranged for Helen to present her helicopter to a select committee of military officials, including some who had previously dismissed her work. The meeting was scheduled for June 1943, just as reports were coming in about a desperate situation developing in the Pacific Theater that would require exactly the kind of capabilities Helen's helicopter could provide. But even as Helen prepared for this crucial presentation, she had no idea that her invention would soon be tested in the most dangerous conditions imaginable, or that the same officers who had laughed at her toy would soon be begging her to rush her helicopters into production to save American lives. Behind enemy lines, the stage was set for one of the most dramatic vindications in military history. And Helen Carter, the woman who had been dismissed as a dreamer building toys, was about to prove that sometimes the most revolutionary ideas come from the most unexpected places. The urgent telegram arrived at Helen's workshop on a humid Tuesday morning in July 1943. It was from Lieutenant Colonel Patterson, and its contents would thrust her helicopter into the most challenging test imaginable. Need immediate deployment. HC-7 Stop Rescue Operation Philippines. Stop lives depend on IT. Stop Patterson. The situation in the Pacific Theater had deteriorated rapidly. A squadron of American reconnaissance aircraft had been shot down over Japanese-occupied territory in the Philippines, and intelligence reports confirmed that at least 12 airmen had survived the crashes. They were trapped in dense jungle terrain, surrounded by enemy forces, and conventional rescue attempts had failed catastrophically. 2 previous rescue missions using traditional aircraft had ended in disaster. The first attempt involved a daring, but ultimately futile mission by a squadron of P-51 Mustangs that were supposed to provide air cover for ground troops advancing through the jungle. The thick canopy and mountainous terrain made it impossible for the fighters to provide effective support, and the rescue team was forced to retreat after suffering heavy casualties. The second attempt was even more devastating. A team of transport aircraft tried to drop supplies and reinforcements to the stranded airmen, but the dense jungle made accurate drops impossible. Most of the supplies ended up scattered across miles of enemy-controlled territory, and the transport planes were easy targets for Japanese anti-aircraft guns. 3 aircraft were lost, and the situation for the stranded airmen became even more desperate. It was then that Lieutenant Colonel Patterson remembered Helen's demonstration. Her helicopter had shown capabilities that no conventional aircraft possessed. It could navigate through tight spaces, hover for extended periods, and land in areas where traditional aircraft couldn't even consider attempting an approach. Most importantly, it could operate at low altitudes and speeds that made it far less vulnerable to the anti-aircraft weapons that had proved so deadly to the rescue flights. When Helen received Patterson's telegram, she didn't hesitate. Within hours, she was on a military transport flight to the West Coast, along with her prototype helicopter and a small team of technicians who had helped develop the aircraft. The HC-7 was disassembled, carefully packed, and loaded onto a cargo ship bound for the Pacific Theater. The journey to the Philippines took 3 weeks, during which Helen worked tirelessly to prepare for the mission. She studied maps of the target area, analyzed weather patterns, and worked with military intelligence officers to understand the enemy positions and capabilities. The more she learned about the mission, the more she realized that her helicopter wasn't just being tested, was quite possibly the only hope for the 12 stranded airmen. The stranded soldiers had been surviving in the jungle for nearly a month by the time Helen arrived at the forward operating base in the Philippines. Radio contact had been sporadic, but the latest intelligence suggested that several of the airmen were wounded and all were suffering from malnutrition and tropical diseases. Enemy patrols were closing in on their position, and it was estimated that they had perhaps 48 hours before they would be captured or killed. General MacArthur himself briefed Helen on the mission. The legendary commander, who had initially been skeptical of deploying an untested aircraft with a civilian pilot, was now desperate enough to try anything. "Dr. Carter," he said, his voice heavy with the weight of command, "those boys are counting on you and your machine. If anyone can get them out, it's going to be you." The mission parameters were daunting. Helen would have to fly her helicopter over 200 miles of enemy-controlled territory, navigate through mountainous jungle terrain where radar was useless, and visual navigation was nearly impossible. Locate the stranded airmen in an area where the jungle canopy was so thick that even aerial photography couldn't penetrate it, and then extract them while under potential enemy fire, making the situation even more challenging was the fact that the HC-7 had never been tested under combat conditions. While it had performed flawlessly during peacetime demonstrations, the stress of combat, the weight of additional equipment, the strain of extended flight times, and the possibility of enemy action could reveal weaknesses that hadn't appeared during testing. Helen spent her final night before the mission going over every system in the helicopter. She checked and rechecked the engine, the rotor mechanisms, the navigation equipment, and the communication systems. Her team of technicians worked alongside her, making final adjustments and ensuring that every component was operating at peak efficiency. As dawn broke over the Philippine jungle, Helen climbed into the cockpit of the HC-7. The helicopter had been modified for the mission. Extra fuel tanks had been installed to extend its range. Medical supplies had been loaded for the wounded airmen, and additional radio equipment had been added to maintain contact with the base. The aircraft was heavier than it had ever been, pushing the limits of its design specifications. The base commander, Colonel Williams, approached the helicopter as Helen completed her pre-flight check. "Dr. Carter," he said, "I want you to know that there are a lot of people here who still think this is a fool's errand. But I've seen what your machine can do, and I believe you can bring those boys home." Helen looked out at the jungle that stretched endlessly toward the horizon, knowing that somewhere in that green maze, 12 American airmen were waiting for a rescue that many believed was impossible. She had spent years developing her helicopter, enduring ridicule and skepticism from colleagues who couldn't see beyond conventional thinking. Now all of that work would be put to the ultimate test. As the HC-7's rotors began to spin, Helen Carter prepared to prove that her toy helicopter was about to become the most important aircraft in the Pacific theater. The helicopter lifted off at 05:45 hours, just as the first light of dawn began to pierce through the morning mist that clung to the Philippine jungle. Helen felt the familiar sensation of the HC-7 responding to her controls. But this time was different. This wasn't a test flight over the safe Connecticut countryside. This was a journey into the heart of enemy territory, where a single mistake could mean death for her and the 12 airmen she was trying to save. The first phase of the mission required flying at extremely low altitude to avoid Japanese radar installations. Helen guided the helicopter through valleys and along riverbeds, using the natural terrain to mask her approach. The HC-7's unique capabilities were immediately apparent, while a conventional aircraft would have been forced to fly high enough to clear the mountainous jungle terrain, making it visible to enemy observers. The helicopter could weave between hills and trees like a mechanical bird. Navigation proved to be one of the most challenging aspects of the mission. The jungle canopy was so thick that landmarks were nearly invisible, and the primitive navigation equipment of 1943 provided only rough guidance. Helen relied heavily on her preparation, following river systems and distinctive mountain formations that she had memorized during her briefings. Every few miles, she would hover the helicopter just above the treetops to get her bearings, constantly aware that each pause made her vulnerable to enemy detection. The intelligence reports had indicated that Japanese forces were concentrated in certain areas, but Helen quickly realized that enemy activity was far more widespread than anticipated. During the first hour of flight, she spotted 3 different enemy encampments that weren't marked on her maps. Each time, she had to make split-second decisions about whether to detour around the positions or risk flying over them at high speed. About 90 minutes into the mission, Helen encountered her first major obstacle. A Japanese patrol boat was moving slowly up a river that she needed to cross. The helicopter's approach had been silent enough that the patrol hadn't detected her, but crossing the river would require flying directly over the boat. Helen made a quick calculation. The HC-7 could accelerate rapidly and cross the river in less than 10 seconds. But those 10 seconds would leave her completely exposed. She decided to take the risk. Dropping the helicopter to just above the water level, Helen accelerated rapidly across the river. The Japanese patrol boat crew spotted her immediately and began firing, but the helicopter's speed and low altitude made it a difficult target. Several bullets struck the aircraft's frame, but none hit critical systems. Within seconds, Helen was across the river and hidden, again among the trees on the opposite bank. The incident highlighted one of the HC-7's most valuable characteristics: its ability to operate in the space between traditional aircraft capabilities and ground vehicle limitations. It was too fast and maneuverable for ground-based weapons to track effectively, yet it could fly low enough to avoid most anti-aircraft systems designed for conventional aircraft. As Helen continued deeper into enemy territory, she began to appreciate other aspects of her helicopter's design that she hadn't fully considered during development. The aircraft's relatively quiet operation was crucial for avoiding detection, and its ability to change direction instantly allowed her to navigate around obstacles that would have been impossible for conventional aircraft to avoid. The most challenging portion of the flight came about 2 hours into the mission, when Helen reached the mountainous region where the airmen were reportedly hiding. The terrain was incredibly treacherous: steep valleys, dense forest, and weather conditions that changed rapidly as altitude increased. Cloud cover that had provided concealment at lower elevations now became a navigation hazard as visibility dropped to mere yards in some areas. It was in this mountainous region that Helen first heard the radio signal she had been hoping for. Faint but unmistakable, it was the emergency frequency that the stranded airmen had been using to communicate with base. "This is Shadow 1, requesting immediate assistance," came the weak voice through the static. "We have wounded and are running low on supplies. Enemy activity increasing in our area." Helen responded immediately. "Shadow 1, this is Rescue Bird. I am approximately 15 minutes from your position. Prepare for extraction." The relief in the airman's voice was palpable as he responded. "Rescue Bird, we can't believe you're actually here. We've been waiting for weeks." Following the radio signal, Helen began the delicate process of locating the exact position of the stranded airmen. They were hidden in a small clearing that was barely visible from the air, surrounded by jungle so dense that it formed a natural camouflage. The clearing was only slightly larger than the helicopter itself, making the extraction far more challenging than anticipated. As Helen approached the clearing, she could see the airmen emerging from their hiding places. They were clearly in poor condition. Several were bandaged, all appeared malnourished, and their uniforms were torn and stained from weeks in the jungle. But they were alive, and they were about to be rescued by the toy helicopter that military officials had dismissed. Just months earlier, the extraction would require precision flying that pushed the HC-7 to its absolute limits. Helen would have to hover the helicopter in a space with mere feet of clearance on all sides, while wounded and weakened airmen climbed aboard. All of this while knowing that Japanese patrols were searching for both the airmen and the mysterious aircraft that had been spotted crossing the river hours earlier. As Helen prepared for the most critical phase of the mission, she realized that everything she had worked for, all the years of development, all the mockery and skepticism she had endured had led to this moment. The success or failure of this extraction would determine not just the fate of 12 airmen, but the future of rotary wing aviation in military operations. The clearing was smaller than Helen had expected, barely 40 feet across, with towering trees creating a natural amphitheater around the stranded airmen. As she brought the HC-7 into a hover, the rotor wash from the helicopter's blades created a whirlwind that bent the surrounding vegetation and stirred up debris from the jungle floor. This was precision flying at its most demanding, with no margin for error. Captain Mitchell, the ranking officer among the stranded airmen, approached the helicopter as Helen maintained her hover. Through the cockpit window, she could see that he was limping badly, and his left arm was in a makeshift sling. Behind him, the other survivors were emerging from concealed positions throughout the clearing, some supporting wounded comrades. "Dr. Carter," Mitchell called out over the noise of the rotors. "We've got 3 men who are seriously wounded and can't walk. We're going to need to load them first." Helen nodded, realizing that the extraction would be more complex than anticipated. The HC-7 had been designed to carry passengers, but loading unconscious or severely wounded individuals would require careful coordination. The first wounded airman was Sergeant Davis, who had suffered a broken leg and possible internal injuries when his aircraft crashed 3 weeks earlier. 2 of his comrades carefully lifted him toward the helicopter's passenger compartment, while Helen made constant micro-adjustments to keep the aircraft perfectly positioned. The slightest movement in any direction could result in the rotor blades striking the surrounding trees, which would be catastrophic for everyone involved. As Davis was loaded into the helicopter, Helen noticed something that made her blood run cold. In the distance, she could hear the sound of voices, Japanese voices, getting closer. The enemy patrol that had been searching for the airmen was approaching the clearing, and the sound of the helicopter had undoubtedly attracted their attention. "We need to move faster," Helen called to Mitchell. "We've got company coming." The captain immediately began organizing his men more efficiently, but the process of loading wounded soldiers into a hovering helicopter in a confined space couldn't be rushed without risking lives. The second wounded airman, Lieutenant Rodriguez, had suffered severe burns when his aircraft caught fire during the crash. He was conscious but weak, and loading him required extreme care. Helen could now clearly hear the Japanese patrol crashing through the jungle vegetation, perhaps only a few hundred yards away. The sound of their voices was getting louder, and she could occasionally make out the metallic sounds of equipment and weapons. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. As Rodriguez was secured in the helicopter, Helen faced a terrible decision. The HC-7 was designed to carry a maximum of 8 passengers under normal conditions, but she now had 11 airmen to extract, including 3 who were wounded and taking up additional space. The aircraft was already approaching its weight limit, and she still had more men to load. "Captain," she called to Mitchell, "we're going to be overweight. This is going to be dangerous." Mitchell looked at his men, then back at Helen. "Doctor, we've been in danger for 3 weeks. We'll take our chances with an overloaded helicopter overstaying here for the Japanese to find." The third wounded airman, Corporal Johnson, had been unconscious for 2 days with what appeared to be a severe concussion. Loading him required 4 men, further crowding the already cramped passenger compartment. Helen could feel the helicopter struggling to maintain its hover as the weight increased, and she had to increase power to compensate. By now, the Japanese patrol was definitely closing in. Helen could hear individual voices and the sound of weapons being prepared. Worse, she could see movement in the jungle at the edge of the clearing, shadows that suggested the enemy was almost upon them. "All right, everyone else, load up now," Mitchell ordered. The remaining 8 airmen began climbing into the helicopter as quickly as possible, but the confined space made it impossible for them to move quickly. Helen had to fight the controls constantly as the weight distribution changed with each person who climbed aboard. With 10 airmen loaded, The helicopter was seriously overweight and handling poorly. Helen knew that attempting to take off with this load would be extremely dangerous, but she also knew that staying on the ground meant certain death or capture for everyone involved. The first Japanese soldiers appeared at the edge of the clearing, just as the 11th Airman was climbing aboard. Helen saw the muzzle flashes immediately and heard the distinctive crack of rifle fire. Bullets began striking the trees around the clearing, and she realized that they were out of time. "Hold on!" she shouted and pulled the collective to begin the takeoff. The overloaded helicopter responded sluggishly, rising slowly from the clearing as more Japanese soldiers appeared and began firing. Helen could hear bullets striking the aircraft's frame, and she saw sparks fly from the engine compartment. HC-7 cleared the trees with less than 2 feet to spare, but Helen knew that the difficult part was just beginning. Flying an overloaded helicopter over 200 miles of enemy territory, with wounded passengers and possible damage to critical systems, would test every aspect of the aircraft's design and her skills as a pilot. As they climbed slowly away from the clearing, Helen looked back to see dozens of Japanese soldiers pouring into the area they had just vacated. The timing had been perfect a few minutes later, and the rescue would have been impossible. But now she faced a new challenge: getting 12 men safely back to base in an aircraft that was operating far beyond its designed capabilities, while flying over territory where enemy forces were now fully alert to their presence. The overloaded helicopter struggled to gain altitude as Helen guided it away from the clearing. With 12 men aboard, 3 of them wounded and unconscious, the HC-7 was carrying nearly 50% more weight than its designed capacity. The aircraft's performance was severely compromised. It climbed slowly, responded sluggishly to control inputs, and consumed fuel at an alarming rate. Helen quickly realized that she would need to modify her flight plan. The direct route back to base would require flying over several mountain ranges that the overloaded helicopter simply couldn't clear. Instead, she would have to follow a longer route through valleys and along coastlines, adding at least an hour to the flight time, while putting additional strain on the aircraft systems. The first major challenge came just 10 minutes after takeoff. The HC-7's engine began showing signs of stress, with temperatures rising beyond normal operating limits. Helen had to reduce power to prevent engine failure, which further decreased their already marginal performance. The helicopter was now flying barely above the treetops, making it vulnerable to small arms fire from ground forces. Captain Mitchell, who had positioned himself near the cockpit, noticed Helen's concern. "How are we doing, Doc?" he asked, trying to keep his voice calm despite the obvious stress of the situation. Helen didn't sugarcoat the reality. "We're heavy. The engine is running hot, and we're burning fuel faster than I'd like. But we're going to make it." The wounded airmen were suffering from the prolonged flight. Sergeant Davis was drifting in and out of consciousness, and his condition appeared to be deteriorating. Lieutenant Rodriguez was in constant pain from his burns, and the helicopter's vibrations were making his injuries worse. Corporal Johnson remained unconscious, which was actually a blessing given the cramped conditions and turbulent flight. About an hour into the return flight, Helen encountered a weather system that hadn't been forecast. Heavy clouds were building over the mountains, and rain was beginning to fall. The HC-7's primitive navigation systems weren't designed for instrument flight, and Helen would have to rely heavily on visual navigation in increasingly poor visibility. Rain created additional problems for the overloaded helicopter. The extra weight of water accumulating on the aircraft's surfaces further reduced performance, and the slippery conditions made the controls even more difficult to manage. Helen found herself constantly fighting to maintain altitude and direction as the aircraft was buffeted by turbulence. It was during this weather encounter that Helen discovered damage from the enemy fire at the clearing. One of the bullets had struck a hydraulic line, causing a slow leak in the system that controlled the helicopter's tail rotor. The damage wasn't immediately critical, but it was getting worse. And Helen knew that a complete hydraulic failure would make the aircraft impossible to control. She made a difficult decision. Rather than continuing to fly low to avoid detection, she would climb to a higher altitude where the thinner air would reduce the load on the damaged hydraulic system. This would make the helicopter more visible to enemy radar and anti-aircraft guns, but it was the only way to prevent a catastrophic system failure. The gamble paid off. At higher altitude, the hydraulic system stabilized, and Helen was able to maintain better control of the aircraft. However, the increased altitude also meant that they were now flying over Japanese-controlled territory in broad daylight, clearly visible to anyone who looked up. About 2 hours into the return flight, Helen's worst fears were realized. She spotted a formation of Japanese fighters climbing to intercept them. The enemy aircraft were much faster than the helicopter, and Helen knew that a direct confrontation would be suicide. However, the HC-7 had one advantage: it could fly in ways that the fighters couldn't match. As the enemy aircraft approached, Helen dove the helicopter toward the jungle canopy, using the helicopter's ability to change direction instantly to make herself a difficult target. The Japanese fighters made several attack runs, but the helicopter's maneuverability and Helen's skilled flying made it nearly impossible for them to get a clean shot. The aerial battle lasted only a few minutes, but it felt like hours. Helen used every trick she could think of, flying through valleys that the fighters couldn't enter, making sudden direction changes that caused the enemy pilots to overshoot, and using the helicopter's ability to hover and reverse direction to confuse her pursuers. Finally, the Japanese fighters broke off their attack. They were running low on fuel and couldn't continue the pursuit. Helen had outmaneuvered them using capabilities that no conventional aircraft possessed, proving once again that her toy helicopter was far more than anyone had imagined. With the immediate threat past, Helen focused on getting her passengers home safely. The wounded airmen were deteriorating, and she knew that speed was now more important than stealth. She pushed the HC-7 to its maximum performance, accepting the increased risk of detection in exchange for reducing flight time. As they approached friendly territory, Helen felt a mixture of relief and exhaustion. The mission had pushed both her and her aircraft to their absolute limits, but they had succeeded. The 12 airmen who had been given up for lost were now just minutes away from safety. The base came into view just as the afternoon sun was beginning to set. Helen could see crowds of people gathered around the landing pad. Then she realized that word of the rescue mission had spread throughout the base. As she brought the HC-7 in for landing, she could see General MacArthur himself standing with the base commander, waiting to greet the rescued airmen. The HC-7 touched down on the landing pad with a gentle thud that marked the end of one of the most daring rescue missions in military history. As the rotors spun down, Helen sat in the cockpit for a moment, hardly believing that they had made it back safely. The mission that had started as a desperate last resort had become a triumphant vindication of everything she had worked to achieve. Medical personnel rushed to the helicopter before it had fully shut down, immediately attending to the 3 wounded airmen. Sergeant Davis, Lieutenant Rodriguez, and Corporal Johnson were carefully extracted from the aircraft and rushed to the base hospital, where Army doctors were standing by to provide advanced medical care. Their survival was itself a miracle. Without Helen's rescue, they would have died in the jungle within days. Captain Mitchell was the first of the uninjured airmen to emerge from the helicopter. Despite his own injuries and 3 weeks of survival in enemy territory, he immediately sought out Helen to thank her. "Dr. Carter," he said, his voice heavy with emotion, "you saved our lives. We had given up hope, and then you appeared like an angel from heaven." The scene at the landing pad was unlike anything the base had ever witnessed. Word of the successful rescue had spread throughout the installation, and hundreds of personnel had gathered to witness the return of the men who had been presumed lost. When they saw the airmen emerging from Helen's helicopter, a spontaneous cheer erupted that could be heard for miles. General MacArthur approached Helen as she completed her post-flight inspection of the HC-7. The legendary commander, who had initially been skeptical of the mission, was clearly moved by what he had witnessed. "Dr. Carter," he said, extending his hand, "you have accomplished something that every expert told me was impossible. You have not only saved 12 American lives, but you have proven that rotary wing aviation has a crucial role to play in modern warfare." The general's words were prophetic. Within hours of the successful rescue, orders were being issued to immediately begin production of additional helicopters based on Helen's design. The War Department, which had dismissed her work as impractical just months earlier, was now demanding to know how quickly she could produce aircraft for operational deployment. Colonel Patterson, who had been the first military officer to recognize the potential of Helen's helicopter, was present for the celebration. "Dr. Carter," he said, "do you remember what General Morrison said about your toy helicopter 2 years ago?" Helen smiled grimly. "He said the Army needed real weapons, not toys that spin around in circles." "Well," Patterson continued, "General, Morrison sent a telegram this morning requesting immediate deployment of 50 of your helicopters to the European theater. It seems that your toy has become the most requested piece of equipment in the Army." The impact of the successful rescue mission extended far beyond the 12 airmen who had been saved. Intelligence reports indicated that Japanese forces in the Philippines were completely baffled by the helicopter's capabilities. They had never encountered an aircraft that could operate in the way Helen's HC-7 had demonstrated, and they were scrambling to develop countermeasures for a technology they didn't understand. More importantly, the rescue had demonstrated capabilities that would revolutionize military thinking about aviation. The ability to extract personnel from areas where conventional aircraft couldn't operate, to provide medical evacuation from forward positions, and to conduct reconnaissance in confined spaces opened up entirely new possibilities for military operations. Within a week of the rescue, Helen received orders to return to the United States to oversee the rapid expansion of helicopter production. The War Department was allocating unlimited resources to the program, and major aircraft manufacturers were competing for contracts to produce her design. The woman who had been working in a small Connecticut hangar with a handful of technicians was now overseeing one of the most important military aviation programs of the war. The rescued airmen made remarkable recoveries. Sergeant Davis required extensive surgery for his internal injuries, but doctors were optimistic about his prognosis. Lieutenant Rodriguez's burns were healing well, and he was expected to return to duty within months. Corporal Johnson regained consciousness 2 days after the rescue and made a full recovery from his concussion. Each of the rescued airmen requested permission to serve as test pilots for the new helicopter program. They had experienced firsthand the capabilities of Helen's aircraft, and they wanted to help develop the tactics and procedures that would make rotary wing aviation an integral part of military operations. The story of the rescue spread rapidly throughout the military and eventually reached the American public. Newspapers across the country ran headlines about the lady engineer and her flying machine, who had saved 12 American lives behind enemy lines. Helen became a celebrity, though she remained focused on the technical challenges of expanding helicopter production. The transformation in military attitudes toward Helen's work was complete. Officers who had previously dismissed her helicopter as impractical were now studying her designs and requesting consultations on how helicopters could be integrated into their operations. The same aircraft that had been called a toy was now being hailed as the future of military aviation. But perhaps the most meaningful recognition came from the 12 airmen she had rescued. They pooled their resources to commission a plaque that was installed in Helen's workshop. It read, "To Dr. Helen Carter, whose courage and vision turned the impossible into reality. From 12 grateful airmen who owe their lives to her toy helicopter. As Helen returned to Connecticut to oversee the expansion of helicopter production, she reflected on the journey that had brought her to this moment. The years of ridicule and skepticism had been vindicated in the most dramatic way possible, and her invention was about to change the nature of warfare itself. Back in Connecticut, Helen's small workshop had been transformed into a bustling production facility almost overnight. The War Department had allocated unlimited funding for the helicopter program, and every major aircraft manufacturer in the country was vying for contracts to produce her design. What had once been a quiet hangar where Helen worked with a handful of technicians was now the epicenter of a revolutionary new industry. The pressure was immense. Military commanders from every theater of operation were requesting immediate deployment of helicopters, each claiming that their missions were the most critical. The European theater wanted helicopters for reconnaissance behind German lines. The Pacific theater was demanding aircraft for island-hopping campaigns where conventional aircraft couldn't operate. The home front was requesting helicopters for search and rescue operations and civilian applications that no one had previously imagined. Helen found herself working 18-hour days, dividing her time between improving the helicopter's design, overseeing production, and training the pilots who would fly these aircraft in combat. The technical challenges were staggering. Each theater of operation had different requirements. Helicopters for the European theater needed to operate in colder climates and carry different equipment than those bound for the Pacific. Aircraft for search and rescue operations required different capabilities than those intended for combat reconnaissance. The first major challenge came from the Navy, which wanted helicopters capable of operating from aircraft carriers. This requirement pushed Helen's design to its limits, as naval operations demanded aircraft that could withstand the corrosive effects of salt water, operate in high winds, and be stored in the confined spaces of a ship. Helen had to completely redesign the folding rotor system and develop new anti-corrosion treatments for critical components. Meanwhile, the Army was requesting helicopters capable of carrying heavier loads and operating at higher altitudes. The mountainous terrain in Italy and the high-altitude operations planned for the invasion of Germany required aircraft that could perform in conditions that Helen's original design had never been tested for. She had to develop new engine configurations and rotor systems that could maintain performance in thin air. The production challenges were equally daunting. Helen's original HC-7 had been hand-built using techniques that were suitable for a single prototype but impossible to scale for mass production. She had to work with manufacturing engineers to develop assembly line processes that could produce hundreds of helicopters while maintaining the precision and quality that made her design so effective. One of the most significant obstacles was the shortage of skilled personnel. Building helicopters required specialized knowledge that didn't exist in the traditional aircraft industry. Helen had to establish training programs for mechanics, pilots, and engineers who would work with rotary wing aircraft. She also had to develop maintenance procedures and spare parts supply chains for aircraft that would be operating in remote locations around the world. The pilot training program was particularly challenging. Flying a helicopter required skills that were completely different from those used in conventional aircraft. Helen had to develop training curricula, write instruction manuals, and personally supervise the training of the first generation of helicopter pilots. Many of these pilots were experienced aviators who had to unlearn traditional flying techniques and develop entirely new approaches to aviation. Captain Mitchell, who had been among the rescued airmen, became one of Helen's most valuable assistants in the pilot training program. His experience with the helicopter's capabilities in combat conditions made him uniquely qualified to teach other pilots how to operate the aircraft effectively. Dr. Carter's helicopter doesn't just fly differently, he would tell new students. It thinks differently. You have to learn to think like the machine. As production ramped up, Helen faced another unexpected challenge: industrial espionage. Intelligence reports indicated that German and Japanese agents were attempting to steal the secrets of her helicopter design. The workshop had to be secured with military guards, and all personnel working on the project had to receive security clearances. Helen herself was assigned a personal security detail after intelligence agencies warned that she might be a target for kidnapping or assassination. The security concerns were justified. In November 1943, FBI agents arrested a German spy who had been working as a janitor in the facility and photographing technical drawings. The incident highlighted the strategic importance of Helen's work and the lengths to which enemy nations would go to acquire her technology. Despite these challenges, production was progressing rapidly. The first production model helicopters rolled off the assembly line in December 1943, just 5 months after the successful rescue mission in the Philippines. These aircraft incorporated numerous improvements based on feedback from the rescue mission and subsequent testing, including more powerful engines, improved navigation systems, and better armor protection. The military's enthusiasm for helicopters was growing exponentially as commanders began to understand the strategic implications of rotary wing aviation. General Patton, who was planning the invasion of Sicily, requested helicopters for reconnaissance missions that would be impossible for conventional aircraft. General Eisenhower, who was coordinating the planning for D-Day, wanted helicopters for search and rescue operations in the English Channel, but perhaps the most significant development was the realization that helicopters could revolutionize medical evacuation. Military doctors who had studied the successful rescue of the wounded airmen in the Philippines recognized that helicopters could transport critically injured soldiers from the battlefield to medical facilities in minutes, rather than hours. This capability could save thousands of lives and change the nature of battlefield medicine. Helen was asked to design a specialized medical evacuation helicopter that could carry wounded soldiers and medical personnel. This aircraft would need to be equipped with medical equipment, have space for stretchers, and be able to operate from improvised landing sites near the front lines. The project represented a completely new application for helicopter technology and required innovations that pushed the boundaries of what was possible with 1943 technology. As 1943 drew to a close, Helen's helicopters were being deployed to combat zones around the world. The toy helicopter that had been dismissed by military officials just 2 years earlier was now considered one of the most important weapons in the Allied arsenal. But Helen knew that the real test of her invention was yet to come. The massive military operations planned for 1944 would determine whether helicopters would remain a specialized tool or become a fundamental component of modern warfare. By early 1944, Helen's helicopters were operating in every major theater of World War II, and the reports coming back from the field were extraordinary. In the Pacific, helicopters were being used for island reconnaissance, allowing Allied forces to assess Japanese defenses without exposing large numbers of troops to enemy fire. In the European theater, helicopters were conducting night reconnaissance missions behind German lines, gathering intelligence that was crucial for planning major offensive operations. The first major test of helicopter capabilities in large-scale combat came during the Allied invasion of Italy. General Clark's Fifth Army had requested helicopters for reconnaissance and communication duties during the assault on the Gustav Line, a series of German defensive positions that had proven nearly impregnable to conventional attacks. Helen's helicopters were tasked with identifying weak points in the German defenses and maintaining communication between forward units and command headquarters. The results exceeded all expectations. Helicopters were able to operate in the mountainous Italian terrain where conventional aircraft couldn't fly effectively. They could hover over suspected enemy positions, provide real-time intelligence to ground forces, and evacuate wounded soldiers from areas that were inaccessible to traditional medical units. The German defenders, who had never encountered helicopters before, were completely unprepared for aircraft that could appear suddenly from behind ridgelines and disappear just as quickly. Lieutenant Colonel Patterson, who had been promoted and assigned to oversee helicopter operations in Italy, sent regular reports back to Helen describing the aircraft's performance. "Your helicopters are changing the nature of warfare," he wrote. "German forces are reporting ghost aircraft that appear and disappear without warning. Their anti-aircraft defenses are designed for conventional aircraft and are completely ineffective against helicopters operating at low altitude." The success in Italy led to expanded helicopter operations throughout the European theater. General Montgomery requested helicopters for the planning of Operation Overlord, the D-Day invasion of Normandy. These aircraft would be used for reconnaissance of the French coast, communication between invasion forces, and search and rescue operations in the English Channel. Helen found herself traveling constantly between production facilities and operational theaters, troubleshooting problems and implementing improvements based on combat experience. Each deployment revealed new capabilities and limitations of her design, requiring constant modification and adaptation. The helicopters operating in the cold climates of Northern Europe needed different engine configurations than those used in the tropical conditions of the Pacific. Aircraft used for medical evacuation required different equipment than those used for reconnaissance. One of the most significant developments was the creation of specialized helicopter units within the military. The Army Air Forces established the 1st Helicopter Squadron in February 1944, with Captain Mitchell as its commanding officer. These units developed tactics and procedures that maximize the helicopter's unique capabilities while minimizing its vulnerabilities. They learned to use the helicopter's maneuverability to avoid enemy fire, its ability to hover for precision operations, and its capacity to operate from improvised landing sites. The Navy's adoption of helicopters proved even more revolutionary. The first naval helicopter operations began in March 1944, when Helen's aircraft were deployed aboard escort carriers in the Atlantic. These helicopters were used for anti-submarine patrols, convoy escort duties, and search and rescue operations. The ability to extend the radar coverage of naval vessels and to rescue downed pilots from the ocean saved countless lives and significantly improved the effectiveness of naval operations. However, the rapid expansion of helicopter operations also created new challenges. The demand for helicopters far exceeded production capacity, and Helen was under enormous pressure to increase manufacturing rates without compromising quality. She had to work with multiple aircraft manufacturers, each with their own production methods and quality control procedures, to ensure that all helicopters met her exacting standards. The maintenance challenges were equally complex. Helicopters operating in combat conditions required more frequent maintenance than conventional aircraft, and the specialized parts and expertise needed for helicopter maintenance were in short supply. Helen had to establish maintenance training programs and develop field maintenance procedures that could be implemented by mechanics with limited helicopter experience. Perhaps the most challenging aspect of the global deployment was the need to adapt helicopters for different combat environments and missions. The helicopters used for jungle operations in the Pacific required different equipment than those used for desert operations in North Africa. Aircraft used for night reconnaissance needed different navigation systems than those used for daylight medical evacuation. Each variation required engineering modifications and extensive testing to ensure reliability and safety. Helen's most ambitious project during this period was the development of a heavy-lift helicopter capable of transporting troops and equipment. Military commanders had recognized that helicopters could revolutionize logistical operations by delivering supplies and personnel to areas that were inaccessible to ground vehicles. However, This application required helicopters that were much larger and more powerful than Helen's original design. The heavy lift helicopter project pushed the boundaries of 1944 technology. Helen had to develop new rotor systems capable of generating the lift needed for heavy loads, more powerful engines that could operate reliably under extreme stress, and structural systems that could withstand the forces generated by large rotors. The project required collaboration with the most advanced engineering firms in the country and access to materials that were normally reserved for the most critical military applications. As Helen worked on these advanced projects, she received reports from the field that highlighted the strategic impact of her invention. German intelligence documents captured during the Italian campaign revealed that Nazi forces were desperately attempting to develop their own helicopter technology. The German military had recognized that helicopters represented a fundamental shift in aviation capabilities, and they were devoting significant resources to developing countermeasures and competing technologies. The global deployment of Helen's helicopters had transformed her from an unknown engineer working in a small Connecticut workshop to one of the most important figures in military aviation. Her invention was saving lives, changing the nature of warfare, and opening up possibilities that no one had imagined just 2 years earlier. But the greatest test of her helicopters was yet to come, the D-Day invasion of Normandy, where her aircraft would play a crucial role in the largest military operation in history. The pre-dawn hours of June 6, 1944, marked the beginning of the largest amphibious invasion in history, and Helen's helicopters were about to play a crucial role in Operation Overlord. 48 of her aircraft had been positioned aboard ships in the English Channel, ready to support the Allied invasion of Nazi-occupied France. The mission would test every aspect of helicopter technology under the most demanding conditions imaginable. Helen herself was aboard the USS Augusta, General Bradley's flagship, where she had been assigned as a technical advisor for helicopter operations. Standing on the ship's deck in the early morning darkness, she could see the massive invasion fleet stretching to the horizon, thousands of ships carrying the hopes of the free world. Her helicopters would be among the first aircraft over the beaches, conducting reconnaissance, directing naval gunfire, and rescuing wounded soldiers. The first helicopter mission of D-Day began at 0530 hours, 30 minutes before the initial beach landings. 2 of Helen's aircraft, piloted by veterans of the Pacific and Italian campaigns, took off from the USS Augusta to conduct reconnaissance of Utah Beach. Their mission was to identify German defensive positions and assess the effectiveness of the preliminary naval bombardment. Flying at extremely low altitude to avoid German radar, the helicopters approached the French coast as the sun began to rise. What they saw was both encouraging and terrifying. The naval bombardment had destroyed many of the German fortifications, but significant defensive positions remained intact. The pilots radioed back precise locations of enemy strongpoints, allowing naval guns to adjust their fire for maximum effectiveness. Ability to hover and observe from stationary positions proved invaluable for directing naval gunfire. Unlike conventional aircraft, which had to make high-speed passes over targets, helicopters could remain in position and provide continuous guidance to naval gunners. This capability significantly improved the accuracy of naval bombardment and helped suppress German defenses before the troops landed. As the first wave of landing craft approached the beaches, Helen's helicopters shifted to search and rescue operations. The aircraft were equipped with flotation devices and rescue equipment, allowing them to land on water to retrieve downed pilots and sailors. The choppy conditions in the English Channel made these operations extremely dangerous, but the helicopter's stability and maneuverability made rescues possible that would have been impossible for conventional aircraft. The most dramatic rescue of D-Day occurred when Captain Mitchell, flying one of Helen's helicopters, spotted a B-24 bomber that had been shot down by German fighters. The aircraft had ditched in the channel about 5 miles from Omaha Beach, and its crew was struggling to survive in the cold water. Mitchell immediately diverted to the crash site, where he found 4 airmen clinging to a life raft in rough seas. The rescue required exceptional skill and courage. Mitchell had to hover the helicopter just above the water while maintaining position in high winds and turbulent conditions. One by one, the airmen were pulled into the aircraft using rescue hoists. The operation took nearly 20 minutes, during which Mitchell and his crew were exposed to potential attack from German aircraft. But all 4 airmen were successfully rescued by midday, as Allied forces were establishing beachheads on the Norman coast. Helen's helicopters were conducting missions that would have been impossible for any other aircraft. They were delivering urgent medical supplies to forward aid stations, evacuating critically wounded soldiers from the beaches, and providing communication links between units that had been separated during the chaotic landings. The medical evacuation missions were particularly significant. Traditional methods of evacuating wounded soldiers from the beaches required dangerous trips by landing craft back to hospital ships, a process that could take hours and often proved fatal for critically injured soldiers. Helen's helicopters could transport wounded soldiers directly from the beaches to hospital ships in minutes, dramatically improving survival rates. One of the most challenging missions occurred when a helicopter was requested to evacuate a critically wounded colonel from a forward command post near St. Vith. The landing zone was under intermittent German artillery fire, and the helicopter would have to hover in an exposed position while the wounded officer was loaded. The pilot, Lieutenant Sarah Chun, one of the first women to fly helicopters in combat, volunteered for the mission. Chun's approach to the landing zone was made under enemy fire, with German shells exploding around the area. She brought the helicopter into a hover just long enough for medics to load the wounded colonel, then immediately took off and flew at maximum speed toward the hospital ship. The colonel survived and later credited the helicopter evacuation with saving his life. The success of helicopter operations on D-Day had strategic implications that extended far beyond the immediate tactical benefits. German intelligence reports captured later in the war revealed that Nazi commanders were completely unprepared for the Allied use of helicopters. The German military had no effective countermeasures for aircraft that could operate at low altitude, change direction instantly, and hover over specific targets. More importantly, the D-Day operations demonstrated that helicopters were not just specialized tools for unique missions, but essential components of modern military operations. The aircraft had proven their worth in reconnaissance, medical evacuation, search and rescue, and fire support roles. Military planners began to recognize that helicopters would be crucial for future operations, not just as support aircraft but as primary combat systems. By the end of D-Day, Helen's helicopters had participated in more than 200 missions, rescued 47 Allied personnel, and provided crucial support for the successful establishment of the Normandy beachhead. The woman who had been dismissed as a dreamer building toys had created the technology that helped make the liberation of Europe possible. As reports of the successful D-Day operations reached the United States, public recognition of Helen's achievement reached new heights. Newspapers across the country ran stories about the flying machines that had helped win the battle for Normandy. But for Helen, the greatest satisfaction came from knowing that her helicopters were saving lives and helping to bring the war to a successful conclusion. The months following D-Day saw an exponential increase in helicopter operations as Allied forces advanced across Europe. Helen's aircraft were now involved in every major military operation. From the liberation of Paris to the crossing of the Rhine, the helicopter had evolved from an experimental curiosity to an indispensable tool of modern warfare, and Helen found herself at the center of a technological revolution that was reshaping military aviation. The final vindication of Helen's work came in April 1945, during the final push into Germany. Allied forces had surrounded Berlin, and intelligence reports indicated that high-value Nazi officials were attempting to escape from the city. A special operation was planned to capture these individuals, but it required inserting troops into the heart of enemy territory and extracting them along with their prisoners. The mission was assigned to a special helicopter unit commanded by Captain Mitchell, using the most advanced version of Helen's aircraft. The helicopters had been modified with additional armor, more powerful engines, and specialized equipment. For night operations, the mission would take them deep into German-held territory, where they would have to operate under the most dangerous conditions imaginable. The operation was a complete success. The helicopters successfully inserted Special Forces troops into central Berlin, where they captured several high-ranking Nazi officials who were attempting to flee the city. The extraction was conducted under heavy fire from German forces, but the helicopters' superior maneuverability and speed allowed them to complete the mission with no casualties. The captured officials provided crucial intelligence about Nazi war crimes and helped Allied forces locate hidden assets. General Eisenhower, who had initially been skeptical of helicopter technology, personally commended Helen for her contribution to the war effort. "Dr. Carter," he said during a ceremony at SHAEF headquarters, "your helicopters have not only saved thousands of American lives, but they have fundamentally changed the nature of warfare. Future military operations will be unimaginable without the capabilities you have given us." The end of the war in Europe in May 1945 marked the beginning of a new chapter in helicopter development. With the immediate military crisis over, Helen was able to focus on applications that had been set aside during the war. She began developing civilian versions of her helicopters for emergency medical services, search and rescue operations, and commercial transportation. The first civilian helicopter service began operating in New York City in September 1945, providing rapid transportation between the city's airports and Manhattan. The service was an immediate success, demonstrating that helicopters could be economically viable for civilian applications. Within months, similar services were established in other major cities, and helicopter manufacturers were receiving orders for civilian aircraft. Helen's work on medical evacuation helicopters proved particularly significant. The techniques developed during the war for evacuating wounded soldiers were adapted for civilian emergency medical services. Helicopters could transport critically ill patients from accident sites to hospitals in minutes, dramatically improving survival rates for trauma victims. The concept of helicopter-based emergency medical services would eventually become standard practice in modern healthcare. The post-war period also saw Helen's recognition as one of the most important engineers of the 20th century. She received numerous awards and honors, including the Congressional Medal of Honor, the first woman to receive this recognition for non-combat service. Universities across the country offered her honorary degrees, and she was elected to the National Academy of Engineering. Perhaps the most meaningful recognition came from the military personnel who had flown and been rescued by her helicopters. Veterans organizations established the Helen Carter Foundation, which provided scholarships for young women pursuing careers in engineering and aviation. The foundation's motto, "From Dream to Reality," reflected Helen's journey from a dismissed inventor to a pioneer who had changed the world. The technological impact of Helen's work extended far beyond the immediate applications of her helicopters. Her innovations in rotor design, engine technology, and flight control systems laid the foundation for decades of advancement in aviation technology. The principles she developed were applied to everything from civilian transport aircraft to space exploration vehicles. By 1950, helicopter manufacturing had become a major industry, with companies around the world producing aircraft based on Helen's original designs. The technology that had been dismissed as impractical in 1943 was now generating billions of dollars in economic activity and providing employment for hundreds of thousands of people. the rescue of the 12 airmen in the Philippines, which had served as the proof of concept for helicopter technology, was remembered as one of the pivotal moments in aviation history. The airmen themselves remained close to Helen throughout their lives, serving as advocates for helicopter technology and reminders of the human cost of innovation. Captain Mitchell, who had been the ranking officer among the rescued airmen, eventually became a general and served as the first director of the Army's helicopter development program. "Dr. Carter didn't just save our lives," he said during a speech at the Smithsonian Institution. "She saved the lives of countless others who would benefit from helicopter technology in the decades to come." As Helen looked back on her career in the 1960s, she reflected on the journey that had taken her from a small workshop in Connecticut to international recognition as one of the most important inventors of the modern era. The skepticism and ridicule she had faced in the early years had been replaced by widespread recognition of her contributions to aviation and humanitarian rescue operations. The toy helicopter that had been dismissed by military officials in 1943 had become the foundation for an entire industry that was saving lives, supporting military operations, and opening up new possibilities for human transportation. Helen's perseverance in the face of skepticism had not only vindicated her own work, but had demonstrated the importance of supporting innovative thinking, even when it challenges conventional wisdom. Her legacy extended far beyond the technical achievements of her helicopters. She had proven that revolutionary ideas could come from unexpected sources, and that persistence in the face of skepticism could change the world. The woman who had been laughed at for building a toy had created one of the most important technologies of the 20th century. The end of World War II did not mark the end of Helen's revolutionary work, but rather the beginning of an even more ambitious chapter in helicopter development. As the world entered the Cold War era, Helen's helicopters found new applications that pushed the boundaries of what anyone had thought possible. The technology that had rescued soldiers from behind enemy lines was about to help humanity reach for the stars. In 1947, the newly formed United States Air Force approached Helen with a classified project that would test her helicopters in ways she had never imagined. The military was developing experimental aircraft that required recovery systems capable of operating in remote locations under extreme conditions. These aircraft were flying at altitudes and speeds that made conventional recovery methods impossible, and helicopters offered the only viable solution. The project required Helen to design helicopters capable of operating at high altitudes in harsh weather conditions. The aircraft needed to be able to lift heavy loads, operate with precision in mountainous terrain, and maintain performance in temperatures ranging from Arctic cold to desert heat. It was a technical challenge that pushed her engineering skills to their absolute limits. Working with a team of the country's most advanced aerospace engineers, Helen developed the HC-15, a heavy-lift helicopter that incorporated technologies that wouldn't become standard in civilian aircraft for decades. The aircraft featured pressurized cabins for high-altitude operations, advanced navigation systems that could operate in any weather, and power plants that could function reliably in extreme conditions. The first test of the HC-15 came in 1948, when an experimental aircraft crashed in the remote mountains of Nevada. The crash site was at an elevation of 12,000 feet, in terrain that was inaccessible to ground vehicles and too dangerous for conventional aircraft recovery operations. Helen personally piloted the HC-15 on the recovery mission, demonstrating that her latest helicopter could operate effectively in conditions that would have been impossible for her original design. The success of the Nevada recovery mission led to expanded military applications for Helen's helicopters. The Army began using helicopters for inserting special forces teams behind enemy lines during the Korean War. The Navy developed helicopter-based anti-submarine warfare systems that extended the reach of naval operations far beyond what had been possible with conventional aircraft. The Air Force used helicopters for recovering pilots who had been shot down in enemy territory, but perhaps the most significant development was the recognition that helicopters could play a crucial role in the emerging space program. As the United States began developing rocket technology, engineers realized that the recovery of spacecraft and astronauts would require aircraft capable of precise operations in remote locations. Helicopters offered the ideal solution for recovering spacecraft that landed in the ocean or in inaccessible terrain. Helen was invited to join the team, developing recovery systems for the Mercury space program in 1958. The challenge was unlike anything she had previously encountered. Helicopters would need to locate and recover spacecraft that could land anywhere in a vast area of ocean, often in rough weather conditions. The recovery had to be completed quickly to ensure the safety of the astronauts, and there was no margin for error. The space program requirements led Helen to develop her most advanced helicopter yet, the HC-20, a specialized recovery aircraft equipped with sophisticated navigation systems, powerful winches capable of lifting spacecraft, and communication equipment that could coordinate with ships and aircraft across vast distances. The helicopter was designed to operate from naval vessels and to maintain precise positioning, even in rough seas. The first test of space-age helicopter recovery came in 1961 during the flight of Alan Shepard, America's first astronaut. Helen's HC-20 was positioned aboard the USS Lake Champlain, ready to recover Shepard's Mercury capsule when it splashed down in the Atlantic Ocean. The recovery was flawless. The helicopter located the capsule within minutes of splashdown, secured it with precision winches, and transported both capsule and astronaut to safety aboard the recovery ship. The success of the Mercury recovery operations established helicopters as an essential component of space exploration. Every subsequent manned space mission relied on Helen's helicopters for astronaut recovery, from the Gemini program through the Apollo missions that would eventually land men on the moon. The technology that had rescued soldiers from Philippine jungles was now bringing astronauts home from space. The space program applications also drove innovations that had immediate benefits for civilian helicopter operations. The navigation systems developed for spacecraft recovery were adapted for civilian search and rescue operations. The communication equipment designed for coordinating with spacecraft was used to improve emergency response systems. The precision flight controls developed for space missions enhanced the safety and reliability of civilian helicopters. As the 1960s progressed, Helen's helicopters were involved in some of the most significant events of the space age. Her aircraft recovered John Glenn after his historic orbital flight, brought the Gemini astronauts home safely, and played crucial roles in the Apollo program that would culminate in the moon landing. Each mission demonstrated new capabilities and applications for helicopter technology. The civilian applications of Helen's space-age innovations were equally impressive. Emergency medical services were revolutionized by helicopters equipped with advanced navigation and communication systems. Search and rescue operations became far more effective with aircraft that could operate in any weather and locate victims. With precision equipment originally developed for spacecraft recovery, Helen's work during this period also contributed to the development of helicopter-based news gathering, aerial construction operations, and offshore oil exploration. The versatility and reliability of her aircraft made them ideal for applications that required precision flying in challenging conditions. By the end of the 1960s, helicopters were being used for purposes that would have been unimaginable when Helen first began developing her toy helicopter. In the 1940s, the recognition of Helen's contributions to space exploration came in 1969. when NASA awarded her the Distinguished Service Medal for her role in the success of the American space program. Dr. Carter's helicopters have been as essential to space exploration as the rockets that launch our astronauts, said NASA Administrator Thomas Paine. Without her innovations, the space program as we know it would not have been possible. As the world prepared for the Apollo 11 mission that would land the first humans on the moon, Helen's helicopters stood ready to bring the astronauts home safely. The same technology that had been laughed at as impractical in 1943 would play a crucial role in humanity's greatest adventure. July 24, 1969, marked one of the most significant moments in human history, and Helen Carter's helicopters played a crucial role in bringing the Apollo 11 astronauts home safely from their historic journey to the moon. As Neil Armstrong, Buzz Aldrin, and Michael Collins splashed down in the Pacific Ocean aboard their command module, Helen's HC-25 recovery helicopter was waiting aboard the USS Hornet, ready to complete the most important rescue mission since those 12 airmen in the Philippines 26 years earlier. The Apollo 11 recovery operation represented the pinnacle of helicopter technology development. The HC-25 was Helen's most advanced aircraft, incorporating decades of innovation and refinement. The helicopter featured redundant systems for critical components, advanced weather radar for operating in Pacific storms, and specialized equipment for handling the Apollo command module's unique recovery requirements. Helen, now 54 years old, and recognized as the world's leading expert on helicopter technology, was aboard the USS Hornet as the senior technical advisor for the recovery operation. Standing on the ship's deck as the Apollo 11 command module descended under its parachutes, she reflected on the extraordinary journey that had brought her from a small Connecticut workshop to this moment, when her technology would help complete humanity's greatest adventure. The recovery operation was flawless. Helen's helicopter located the command module within minutes of splashdown, despite rough seas and challenging weather conditions. The precision system she had developed allowed the aircraft to maintain perfect positioning while Navy divers secured the spacecraft. Within 30 minutes of splashdown, the 3 astronauts were safely aboard the USS Hornet, completing their historic journey with the help of technology that had been dismissed as a toy just decades earlier. The success of the Apollo 11 recovery was broadcast live to television audiences around the world, and Helen's helicopters became symbols of American technological achievement. The images of the helicopter lifting the command module from the Pacific Ocean were seen by more than 650 million people worldwide, making it one of the most watched helicopter operations in history. But the impact of Helen's work extended far beyond the space program. By 1970, helicopters based on her designs were operating in every country in the world, serving applications that spanned the entire range of human activity. Emergency medical services, search and rescue operations, news gathering, construction, agriculture, and transportation had all been revolutionized by the versatility and capabilities of rotary wing aircraft. The medical applications of Helen's helicopters were particularly significant. Hospital-based helicopter services, which had begun as adaptations of military medical evacuation techniques, were saving thousands of lives every year. Trauma patients who would have died in conventional ambulances were surviving because helicopters could transport them to advanced medical facilities in minutes rather than hours. The concept of the golden hour in emergency medicine became possible only because of helicopter-based medical services. Helen's helicopters were also playing crucial roles in disaster relief operations around the world. When earthquakes, hurricanes, floods, or other natural disasters struck, helicopters were often the only aircraft capable of reaching victims in devastated areas. The same capabilities that had allowed her aircraft to operate in the Philippine jungle during World War II made them ideal for delivering supplies and evacuating victims from disaster zones. the commercial applications of helicopter technology were equally impressive. Offshore oil exploration, which had been limited to shallow coastal waters, was extended to deep ocean locations because helicopters could transport personnel and equipment to drilling platforms that were beyond the range of conventional aircraft. Construction projects in remote or difficult terrain became feasible because helicopters could transport materials and workers to locations that were inaccessible to ground vehicles. Helen's innovations also contributed to scientific research in ways that she had never anticipated. Helicopters equipped with specialized instruments were being used to study wildlife in remote locations, monitor environmental conditions in pristine ecosystems, and conduct geological surveys in areas that had never been explored. The same precision and versatility that made helicopters effective for military and rescue operations made them invaluable tools for scientific research. The international impact of Helen's work was recognized in 1971 when she became the first woman to receive the International Aeronautical Federation's Gold Medal, the highest honor in aviation. Representatives from more than 50 countries attended the ceremony, acknowledging that helicopter technology had become a global phenomenon that transcended national boundaries. During her acceptance speech, Helen reflected on the journey that had brought her to this moment of international recognition. "When I first began working on helicopter design," she said, "I never imagined that these aircraft would become so essential to human welfare around the world. The technology that started as a solution to rescue stranded soldiers has become a tool for saving lives, advancing science, and connecting communities in ways that would have been impossible just a generation ago." The speech was broadcast internationally and became one of the most quoted addresses in aviation history. Helen's message resonated with audiences around the world. That persistence in the face of skepticism, combined with a commitment to solving human problems, could lead to innovations that changed the world. By the mid-1970s, helicopter manufacturing had become a multi-billion-dollar global industry. Companies in the United States, Europe, Asia, and other regions were producing aircraft based on principles that Helen had first developed in her Connecticut workshop. The technology transfer and licensing agreements for her patents had created a network of international cooperation that contributed to peaceful relations between nations. Helen's helicopters were also contributing to cultural exchange and understanding. News organizations were using helicopters to provide live coverage of events around the world, giving people unprecedented access to information about different cultures and societies. Tourism was being revolutionized by helicopter services that could transport visitors to remote and beautiful locations that had previously been inaccessible. The educational impact of Helen's work was equally significant. Engineering schools around the world were teaching helicopter design principles as fundamental components of aerospace education. Thousands of young engineers were building careers based on technologies that Helen had pioneered, ensuring that innovation in rotary wing aviation would continue for generations to come. As the 1970s progressed, Helen began to focus on the next generation of helicopter technology. She was working on designs that incorporated advanced materials, computer-controlled flight systems, and propulsion technologies that would make helicopters even more capable and efficient. The woman who had revolutionized aviation once was preparing to do it again. As Helen Carter entered the final decades of her remarkable career in the 1980s, she had the rare privilege of witnessing the full flowering of her life's work. The toy helicopter that had been ridiculed by military officials in 1943 had evolved into one of the most important technologies of the modern world, touching virtually every aspect of human activity and saving countless lives around the globe. Statistics were staggering. By 1985, helicopters based on Helen's original designs were conducting more than 3 million flight hours annually worldwide. Emergency medical helicopters were saving an estimated 50,000 lives per year in the United States alone. Search and rescue operations had a success rate that was 10 times higher than pre-helicopter era operations. Military forces around the world had adopted helicopter-based tactics that had fundamentally changed the nature of modern warfare. But for Helen, the most meaningful measure of her success wasn't found in statistics or technical achievements. It was found in the individual. Stories of lives saved and human suffering alleviated by her technology. Letters arrived daily from people around the world whose lives had been touched by helicopter operations. A mountain climber rescued from an impossible location. A heart attack victim saved by rapid medical transport. A family evacuated from a natural disaster. Soldiers brought home safely from combat zones. One letter that particularly moved Helen came from Maria Santos, a young woman in the Philippines whose father had been rescued by helicopter after a typhoon in 1983. Dr. Carter. The letter read, "You probably don't remember the American soldiers rescued from our islands during the war, but their rescue inspired our country to develop its own helicopter rescue services. Last month, your technology saved my father's life when our village was flooded. Your invention continues to save lives decades after you first flew into our skies." Helen did remember those 12 airmen from 1943, and she had remained in contact with many of them throughout their lives. Captain Mitchell, now a retired general, had become one of her closest friends and advisors. In 1986, the surviving members of that original rescue mission gathered for a reunion at Helen's Connecticut workshop, which had been preserved as a historical landmark. "Dr. Carter," General Mitchell said during the reunion, "when you flew into that jungle clearing 43 years ago, you saved 12 lives. But looking at what your helicopters have accomplished since then, I think you've actually saved millions of lives. That rescue mission was just the beginning." The reunion was covered by news organizations around the world, and the footage of the elderly veterans embracing the woman who had saved their lives became one of the most moving human interest stories of the decade. The image of Helen, now in her 70s but still sharp and energetic, surrounded by the men whose rescue had launched the helicopter age, symbolized the profound human impact of technological innovation. As Helen looked back on her career, she was particularly proud of the role her helicopters had played in advancing women's participation in aviation and engineering. The success of her technology had opened doors for countless women who followed in her footsteps. By the 1980s, women were serving as helicopter pilots, engineers, and commanders in military and civilian operations around the world. Lieutenant Sarah Chun, who had flown one of Helen's helicopters during D-Day, had risen to become the first woman general in the Army Aviation Branch. Dr. Jennifer Walsh had used Helen's success as inspiration for her own groundbreaking work in aerospace engineering. Hundreds of other women had built careers in aviation and engineering, citing Helen's example as proof that gender was no barrier to technical achievement. Helen's influence extended beyond technology to fundamental changes in how society viewed innovation and problem-solving. Her story had become a standard case study in engineering schools, business programs, and leadership courses around the world. The key lessons from her experience: the importance of persistence in the face of skepticism, the value of unconventional thinking, and the necessity of focusing on human needs rather than technical elegance, had influenced a generation of innovators and entrepreneurs. The Helen Carter Institute for Advanced Aviation Research, established at MIT in 1987, became the world's leading center for rotary wing aviation development. The Institute's mission was to continue the innovative work that Helen had begun, pushing the boundaries of helicopter technology to address emerging challenges in transportation, emergency services, and scientific research. As Helen prepared to retire from active engineering work in 1989, she reflected on the extraordinary journey that had taken her from a young woman fascinated by flight to one of the most influential engineers of the 20th century. The path had not been easy. She had faced skepticism, ridicule, and discrimination that would have discouraged many others. But her persistence and faith in her vision had ultimately transformed not just aviation technology, but society's understanding of what was possible. In her final public address, delivered at the Smithsonian Institution in 1990, Helen offered advice to future generations of innovators. The most important inventions often come from the most unexpected places and the most unconventional thinkers. When experts tell you that something is impossible, remember that they said the same thing about my toy helicopter. Trust your vision. Persist through the skepticism, and never forget that the ultimate purpose of technology is to serve human needs. Helen Carter passed away peacefully in 1995, at the age of 80. Her funeral was attended by representatives from every major helicopter manufacturer in the world, military officials from dozens of countries, and hundreds of people whose lives had been saved by her technology. The woman who had been laughed at for building a toy helicopter was honored as one of the most important innovators in human history. Today, as helicopters continue to evolve with new technologies like autonomous flight systems and electric propulsion, they still operate on the fundamental principles that Helen Carter established in her small Connecticut workshop more than 80 years ago. Every helicopter that lifts off to rescue disaster victims, transport patients to hospitals, or explore remote frontiers carries with it the legacy of a woman who refused to accept that the impossible was truly impossible. The 12 airmen she rescued from behind enemy lines in 1943 could never have imagined that their rescue would mark the beginning of a technological revolution that would save millions of lives and change the world forever. But that is exactly what happened, because one woman had the vision to see beyond the skepticism and the courage to pursue what others dismissed as merely a toy. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.